Our next topic is decimals. Now, one thing to keep in mind about decimals is that they're really related to fractions. In fact, decimals are a form of a fraction with a special denominator. And the denominator is always some power of 10. So if we think about what we talked about with fractions, it was really important to know how we identified a whole. Let's imagine that this square represents one whole. If we divide that square up into 10 equal pieces, then we have 10 tenths. And if we divide that whole into 100 equal pieces, we have 100 hundredths. Well, tenths and hundredths are decimal numbers. Decimal numbers are based on powers of 10 in the denominators of fractions, and those powers of 10 in the denominator dictate how we say a decimal number. So let's think about place value. And we've already talked about place value when it comes to whole numbers. So if we look at this number, we would say that's the number 163. We know that the 1 is in the hundreds place, the 6 is in the tens place, and the 3 is in the ones place. So we have 1 100, 6 tens, and 3 ones. The decimal point in a decimal number separates the whole number of units from the fractional parts of a unit. Now, if we have this number, we would say 163 and 9 tenths. The 9 tenths is a fractional part of a whole. It's 9 tenths of a whole. This number would be 163 and 90 hundredths. This would be 163 and 904 thousandths. This number would be 163 and 9,042 ten-thousandths. This number is 163 and 90,427 100,000ths. And this number is 163 and 904,278 millionths. Now we could continue and keep naming place values after the decimal point, but what's important to notice is that the digits behind the decimal point, the digits to the right of the decimal point, represent fractional parts of a whole. Now when we say decimal numbers, there's sometimes a lazy way that we say them. If we look at this decimal, quite often we'll say it as 0.24. And while that's a perfectly good way to say this number in kind of a general sense, it's not a very mathematical sense. So we really want to say this number as 24 hundredths. That name 24 hundredths is telling us what part of the whole this number represents. If we think about our whole as being divided into 100 hundredths, then 24 hundredths would be this yellow part of the whole. Now, if you think about that, and the fact that the whole is divided up into 100 equal pieces, we could also take those 24 hundredths and regroup them so that we would have 2 tenths plus 4 hundredths. And in fact, that's a way to think about the number 0 and 24 hundredths in terms of its fractional parts and place value. The 2 is in the tenths place, so it represents 2 tenths, and the 4 is in the hundredths place, so it represents 4 hundredths. So 0 and 24 hundredths is really saying we have no wholes, 2 tenths, and 4 hundredths. Now we could also write that same expression using decimals. We could say 0 and 24 hundredths is 2 tenths, written as a decimal, plus 4/100 written as a decimal. So let's think about this number 163 again. The 1 is in the hundreds place, the 6 is in the tens place, and the 3 is in the ones place. Digits after the decimal also have place value that is based on fractions with denominators that are powers of 10. So the 9 is in the tenths place, the 0 is in the hundredths place, the 4 is in the thousandths place, and so on. And remember, we can also write place value in terms of powers of 10. So 100 is the same thing as 10 to the second power, 10 is 10 to the first power, 1 is 10 to the 0 power, 1/10 is 10 to the negative first power, 1/100th is 10 to the negative second power, 1/1000th is 10 to the negative third power. Now, knowing what the place value of these digits is allows us to write expanded form for decimals. So let's say we'd like to write this number in expanded form using fractions for place value. So the 2 is in the ones place. The 2 is a whole number of ones. Plus we have a 6 in the tenths place, so that represents 6/10ths. And we have a 7 in the hundredths place, so that represents 7/100ths. So writing these separate terms and then adding them is what we have been calling expanded form. And if we would choose to write expanded form using negative exponents instead of fractions, the 2 is still in the whole number place, the ones place. 6 is in the tenths place, so it represents 6 times 10 to the negative first. And 7 is in the hundredths place, so it represents 7 times 10 to the negative second. So that's another example of writing this number 2 67/100ths in expanded form, but this time we've used negative exponents. Now let's think about these decimal numbers and the fact that even then when they don't look the same, they can represent the same value. So the question is 6/10ths equivalent to 60/100ths? Does it represent the same value? Well, the answer is yes, and it's pretty easy to see if you look at some area models. If the square represents a whole, then what you see on the left represents 6/10ths. It's the whole divided into 10 equal pieces. Each one of those pieces is a tenth, and 6 of the tenths are shaded in. On the right, you see a square that represents one whole. It's divided into 100 equal pieces, and 60 of the 100 pieces are shaded in, so that's 60/100ths. And it's easy to see that the amount that's shaded in each of these equal wholes is the same, so the two decimal numbers must be equivalent. Now, since decimal numbers really do represent whole numbers and fractional parts of a whole number, we can always represent a decimal number as a fraction. So let's take this decimal number, 4 32/100ths, and write it as a fraction. Now, if we just say the number like we're supposed to, 4 32/100ths, we can write what we just said as a mixed number, 4 32/100ths. Now we're almost there. We want a single fraction. So we're going to have an improper fraction that means the same thing as 4 32/100ths. And that would be 432 over 100, which can be simplified as 108 over 25. So 4 32/100ths written as a single fraction is 108/25ths. How about if we have a fraction and we want to write it as a decimal? Well, that can be a little trickier. Sometimes if we look at the fraction and we notice that there are some convenient things going on in the denominator, writing the fraction as a decimal can be pretty simple. In this case, 20 is a factor of 100, so proportions might be a simple way to write this as a decimal. So we can say 3/20 is the same thing as some number of 100ths. Since 20 times 5 is 100, 3 times 5 is 15. So we have equivalent fractions. 3/20 is the same thing as 15/100ths. Now what's important about 15/100ths is it's a fraction that has a denominator that's a power of 10, which means 15/100ths really represents a decimal number. And if we write that fraction 15/100ths as the decimal that it represents, 0.15, we've got 15/100ths written as a decimal as well. So 3/20ths is equivalent to 15/100ths. The other method that we can use to write a fraction as a decimal is to use division. In this case, we're going to think of the fraction bar as being a division sign. So 3/20ths is the same thing as 3 divided by 20. Now we haven't talked about decimal division in detail yet, but certainly you know how to do a decimal division, and we will talk more about this in the not too distant future. But if we take 3 and divide it by 20, we will get that same decimal number, 0.15 or 15/100ths. Now decimal numbers can either terminate or they can repeat. A terminating decimal is a decimal number that can be written with a finite number of digits. In other words, the decimal number will stop. So if we write the number 24.777, 24 and 777 thousandths, that terminates because it has a last digit. On the other hand, if we see 3 dots behind that number, we know that those 3 dots mean that we have something that goes on infinitely. So the 3 dots in this case, the ellipses, are telling us that those 7s will go on forever and ever and repeat that pattern. So this would be a repeating decimal. Now when we look at a fraction, we said that we can write fractions as decimals. And if we look at a fraction, if we look at a rational number, and we want to know if it can be written as a terminating decimal or can it be written as a repeating decimal, then what we need to do is look at the factors of its denominator. And if the only prime factors of its denominator are 2, or 5, or some combination of 2s or 5s, then that rational number can be written as a terminating decimal. The only thing we have to be careful of here is that before we make this decision about whether a fraction can be written as a terminating decimal, we have to look to see that the fraction is simplified. So let's look at some fractions and see if we can figure out whether they would represent a terminating decimal. And let's start with this, 7/40ths. Now the first thing we're going to check is to make sure that's a simplified fraction, and it is. So the next thing we're going to do is look at the denominator, the 40, and think about what the prime factors of 40 are. Now we can make a factor tree to find the prime factors of 40, which are 2 and 2 and 2 and 5. So the only factors of the denominator are 2's and 5's, which means if we were to write this fraction as a decimal, it would terminate. It would have a last digit. How about 9/30ths? Does that represent a terminating decimal? Now remember, the first thing we have to do is simplify this fraction. So 9/30ths is not simplified. We can divide numerator and denominator by 3 and simplify this fraction to 3/10. Now look at the denominator, it's 10. We want to check to see what the prime factors of 10 are. And since 10's only factors are 2 and 5, this fraction will terminate if we write it as a decimal. How about 5/30ths? Well, if we want to know if it would be represented by a terminating decimal or a repeating decimal, we need to simplify it first. And there is a common factor of 5 in the numerator and denominator. So this fraction simplifies to 1/6. Now think about its denominator, 6. What are the prime factors of 6? Well, 6 is 2 times 3, and that 3 is going to cause this to be a repeating decimal if we write it as a decimal. How about 1/8? Well, first of all, is 1/8 simplified? And it is. So think about the factors of 8, the prime factors. 8 could be factored into 2 times 2 times 2. So the only factors of that denominator are 2's. That means that if we were to write 1/8 as a decimal number, it would terminate. So decimal numbers represent real numbers on a number line. We could find a home for them on the number line, which means we could find a way to decide which numbers are greater than other numbers. We could put them in order. So let's do that with these decimal numbers. We have 3 64/100ths, 3 6/10ths, 3 649,000ths, and 3 613,000ths. Well, let's take the numbers and let's just write them vertically so that we can compare digits in each place. We can compare digits, the value of the digits in the same place, to see if we can figure out which numbers are the least and which numbers are the greatest. Now there's another thing we might want to do here too. You'll notice that the numbers have different numbers of digits after the decimal point. For example, 3 64/100ths has 2 digits after the decimal point. 3 6/10ths has only 1. 3 649,000ths, there's 3 digits after the decimal point. That's not really a problem, but it could make it a little more tricky to compare these numbers. So what we're going to do is try to rewrite the numbers so that they all have the same number of digits behind the decimal point. Now, doing that won't change the value of the numbers. For example, 3 64/100ths is going to be exactly the same as 3 640,000ths because all we've done is add 0 thousandths to the number. Same thing with 3 6/10ths. If we add those 2 zeros on after the 6, what we've added to that number is no hundredths and no thousandths. So we have not changed its value. But now maybe we can compare these numbers a little more easily. So if we look at all of them and look at the whole number that we have to the left of the decimal, every one of these numbers has 3 wholes in it. So in terms of their wholes, they have exactly the same value. If we look at the number in their tenths place, they all have 6/10ths. So that part of them's the same. If we go to the hundredths place, we start to see a difference. The first number has 4 hundredths, the second number has no hundredths, the third number has 4 hundredths, and the last number has 1 hundredth. And we're looking for the least number, which means 3 6/10ths, which we now have written as 3 600,000ths. That is the smallest number. So we're going to mark it with a 1 and then mark it off the list because we've already ordered it. It is the smallest number. Now we're still comparing. Look at that hundredths place. We have in the 3 640,000ths, there's 4 hundredths. And then there's also 4 hundredths in the 3 649,000ths, but there's only 1 hundredth in the very last number, 3 613,000ths. So it has got to be the second smallest numbers. Cross it off. All right, so now we're down to the last 2 numbers. We want to know which one is the smallest. They both have 3 wholes. They both have 6/10ths. They both have 4 hundredths. But the first number has no thousandths, which is less than the remaining number underneath that, which has 9 thousandths, which means that is our third number, and this is our fourth number, And now if we write them as the numbers they were originally, we have them in order from least to greatest. 3 and 6/10, 3 and 613 thousandths, 3 and 64 hundredths, and 3 and 649 thousandths. So our last topic is scientific notation. And we're going to talk about scientific notation because it also is a way of expressing numbers using powers of 10. A number is written in scientific notation if it's in the form n times 10 to the r power, where n is a number between 1 and 10. It could be 1, but it can't be 10. And r is an integer. Now, scientific notation is a really nice way to take really large numbers or really small numbers and write them in a much more compact form. Let's take a look at some numbers that are written in scientific notation just to see what it looks like. This is a number written in scientific notation, 3.603 times 10 to the 7th power. The number that we see in front of the multiplication sign is between 1 and 10. And the power on the 10 is an integer, it's 7. This number is also in scientific notation. The number in front of the multiplication sign is between 1 and 10. And the number after that is 10 raised to a power that's an integer. The integer is -3. These numbers are not in scientific notation. Think about why they're not. In this case, the 32.63 is not a number between 1 and 10. So this number is not in scientific notation. And in this case, the number in front of that multiplication sign is between 1 and 10, so that's not the problem. The problem is the power on the 10. -1.5 is not an integer, so that number is not in scientific notation. So how do we write numbers in scientific notation? We'll start with this number, 36,500. What we have to think about is what would we like the first part of our number in scientific notation to look like? We would really like it to be a number between 1 and 10. So we wish that the decimal point were right there between the 3 and the 6. Unfortunately, it's not. The decimal point in our original number is behind that second 0. So, how do we get that decimal point to move from where it was to where we'd like it to be? We do that with those powers of 10. Now we need to introduce that power of 10 here because obviously 36,500 is not the same as 3.65. So we're going to do some counting. 1, 2, 3, 4. We need to move that decimal point 4 places to get it from where it was to where we'd like it to be. And that 4 is important because that tells us the power on the 10. So 36,500 is the same thing as 3.65 times 10 to the 4th power. And if you stop and think about it, 10 to the 4th power is 10,000. So 3.65 times 10,000 is 36,500. How about if we have a very small number and we want to write it in scientific notation? We can do exactly the same thing. We can say, well, where do we need that decimal point to be so that that number in front of the multiplication sign is between 1 and 10? And that's where we need it to be. We need it to be between the 2 and the 4, so we have the number 2.4. Now those two numbers aren't equal to each other, obviously. 24 thousandths is not the same thing as 2.4, which is why we need to multiply by a power of 10. So we'll look to see how far that decimal point would have to move to get it to a place where we would have that 2.4. And it would have to move 2 places. Now here's the important thing about those 2 places. Obviously, 0.024 is not the same thing as 2.4. 24 thousandths is not the same thing as 2 and 4 tenths. That's why we need to multiply 2 and 4 tenths times some power of 10. But we really need to divide 2 and 4 tenths by something to turn it into this small number, 24 thousandths, which means the 2 that we see, as in we move the decimal point 2 places, actually has to be a negative exponent on the 10. Now, one thing to look for when you're trying to figure out whether exponents are negative or positive in scientific notation is to think of this. If you have small numbers like we just had, 24 thousandths, a very small number in what's called standard form has a negative exponent in scientific notation. And a large number in standard form, like that 36,500, large numbers have positive exponents on the 10 in scientific notation. So that's our look at decimals. Decimals are probably something you're very familiar with, but you're still going to have to make sure that you understand how they work and understand why they work the way they do.